All right, this is our last warm up. Make sure you get all 10 done for that extra formal grade. Here we go. ACT warm up number 10, goal number 1, number and operations. On a test, Caleb answered 73 out of 86 questions correctly. What portion of his answers was correct? That should be were. Write your answer as a decimal round to the nearest thousandth. That just means the division. So 73 out of 86. Portion, percent, proportion, all kind of interchangeable. 73 divided by 86. And it says round to the nearest thousandth. So thousandth is 3 decimal places out. So rounding tip 101. When you're rounding to the nearest thousandth, so if you're going 3 decimal places out, so go to that third spot. If the number to the right of that is 5 or higher, you bump this number up. If it's 4 or lower, 4, 3, 2, 1, or 0, you'd keep it. So since this is an 8, we're going to round this to 0.849 because the next number is higher than 5. So that portion is 0.849 or 84.9%. We're going to leave it as a decimal. But you can see 84.9% is also another way to represent that. All right, question 2. A scale model of a building is 8 inches by 12 inches by 6 inches. If the scale is 1 inch equals 15 feet, what is the volume of the actual building? So volume is just length times width times height, which we have as a scale model, but we got to multiply first. So the actual dimensions are going to be, well, if 1 inch is 15 feet, you would just say 8 times 15, 12 times 15, and 6 times 15. And we'll plug in our length, width, and height. It doesn't matter which one's length, width, or height. They all get multiplied. So let's do that. So 120, 80, and 90. 120, 80, and 90. So our volume is going to be 120 by 80 by 90. So let's see what that equals. Oh, that's 180, not 80. So let me put that 1 in there here. So that's a big number, 1944000. 1944000. Volume is measured in cubic, whatever the unit is. So this is feet, so we'd say feet cubed. The second part of number 2 is talking about another scale issue. So the actual distance from Portland to Seattle is 75 miles. If the map is 1 1/4 inches equals 2.25 miles, what is the actual distance? What is the distance in inches between the two towns on the map? Well, 1 1/4 is 1.25. So I'm going to do that first. And in this case here, if I know that the actual distance is 75 miles and I want to know the distance in inches, I'm going to set up a proportion. So I'm going to say 1.25 inches is to 25 miles as whatever amount of inches we're trying to find, we don't know, is to 75 miles. So we'll do a proportion. Now you might be able to say, well, 25 times 3 is 75. I could do 1.25 times 3, which is fine. You can also do cross multiplication. So we could do 1.25 times 75 and 25 times x, and then solve that equation. So we do 25x equals 1.25 multiplied by 75. So in this problem, what I would do is I would divide that 25 out. And you can see 75 divided by 25 is 3. So it's really just 1.25 times 3. So x is going to be 1.25 times 75 divided by 25, or 1.25 times 3. See, either way, you could do 1.25 multiplied by 3 because these two divide by 3. So 3.75 is going to be the actual distance on the map. And that's going to be in inches. All right, get that down. I'm about to race number 2. So pause the video if you need to. Number 3, Sally is making preparations for her wedding celebration. She is ordering a cake, but wants to make sure she will have enough to feed her guest. Her one guest. Let's make that guests. Her cake will consist of 2 cylindrical molds stacked on top of each other. 2 cylindrical molds stacked on top of each other. Cylindrical, cylinder. So, you know, a layer of a cake. Cylinder 1. Cylinder 2. And of course, those are going to be stacked on top of each other. So let's see what we got. The top mold will be 8 inches high with a 5 centimeter radius. So the radius is this distance here. Let me do that in blue so I don't confuse you color coding people. So 5 inches. Oh, I just made that 5 inches. And then the height would be 8. The bottom will be 10 inches high with a 24-inch diameter. So that's 10. Now, a 24-inch diameter, that's all the way across. We have to divide that by 2 to get the radius. So the radius is actually going to be 12 because the radius of that is 24 divided by 2. 24 divided by 2 is 12. So we're going to use 12 inches. So it's a wider bottom than the top. So it looked more like this, which makes more sense, I guess, if it's a layered wedding cake, right? Because you have that, and then you have something like that. Pardon my drawing there. I'm terrible at this, especially in the computer. So it's going to look more like that. What will be the volume of our cake? How much icing will the baker need to cover the cake? I don't know. Oh, that's square. Yeah, we're not going to do that because that's a little bit more involved. That's area, but there's so much missing area here. That's not going to happen. So let's get the volume. The volume of a cylinder is pi r squared. That's the area of the circle, multiplied by the height. So we got 2 volumes. We're going to add them together. So we're just going to focus on that. We don't need the icing part because that's going to be a hard area problem. So that's going to be pi times, we got 2 cylinders. So let's take the bottom one first. That's going to be pi times 12 squared multiplied by 10. And then the top one will be pi times 5 squared multiplied by 8. And then we want to add those together since it's combined. So go into your calculator on your TI calculator. If you're using one of these, you have a pi button. You can just press second divided by, or sorry, second, oh, it's hard to see that. Second, that button there, that's the exponent button, and that'll get you pi. And then you can do all the rest. On here, you can access pi down here in the menu. If you go down to the calculator, and you can hit that pi button, or what I do is the keyboard shortcuts. So I just do pi, just type pi, and there's pi. So pi times 12 squared multiplied by 10. There's your bottom, and then the top is pi times 5 squared times 8. So those two add together. I'm just going to round the 2 decimal places. And your combined volume is about 5152.21. So we'll say 5152.21. What is the unit? Well, we'd say, since this is in centimeters, centimeters cubed. All right, that was number 3. Get that down. I'm about to clear it off. Go to number 4. Okay, question number 4. Make a cumulative frequency table and histogram for the following data in the stem and leaf plot. Cumulative frequency table and a histogram. Let's start with the histogram. I think y'all might know what that is more than cumulative frequency table. A histogram is basically, it's like a bar graph, but what you do is, let's see here. You got the numbers 11. The key here is 3, 2 is 32. So this would be 11. And then you have 20. And then you have another 20. Then you have a 21 and a 26. This is 32 and 37 and 40 and 48. So those are the actual numbers. There's 1, 2, 3, 4, 5, 6, 7, 8 numbers. And that first number is the tens place. The second number is the ones place, okay? So the histogram, the way that's gonna work is the bottom row is just gonna be, let's say you wanna start, you have to kind of count in the same increment. So let's say I might start at 10. And then all the numbers between 10 and 20. It doesn't say what to stop. I could do 5s or whatever, but all numbers to 10 and 20. So 10, 11, 12. So anything that's greater than or equal to 10 and less than 20 is in there. And then I do all the numbers between 20 and 30. So 20, 20, 21, 26. And then all the numbers between 30 and 40. And I just keep that consistent. I count to 50. And then I'm going to make basically 4 bars. That first bar only is going to have 1 because it's 11, right? So my counts are going to be over here. We call this the frequency. It's just how often something occurs. So if I have 11, that's going to happen once, one thing between 10 and 20. That's 11. And then I have 1, 2, 3, 4. So 20, 20, 21, 26. I have 4 things going on in there. Now you can make your bars narrower too. You can go by 5s, whatever you want. I'm just doing 10s. I have 2 here. So I'm going to count that up to 2. And I have another 2 here. So that would be a histogram. Cumulative frequency table is essentially the same thing, but just in a table format. So like you could say 10 to, I really should say like 19 there, but whatever, 10 to 20, or x is between, greater than or equal to 10, but less than 20. And then x is greater than or equal to 20, but less than 30. Or you could say 21 to 30. And then x is greater than or equal to 30, but less than 40. And greater than or equal to 40, but less than 50. And basically all you're doing for the table is the frequency is just how many you see there. So I see 1, 4, 2, and 2. So it's just right from here, 1, 4, 2, and 2. That's cumulative frequency table, but then I find more power in a graph personally. So that's why I did that first. Okay, clear that off. Number 5, next. What is a missing number in the function table? Hint, find a rule first. All right, let's see what's going on. So we got -4 to -2 to 1 to 4, -5, -1, 5. So let's look for a pattern. This is going up 2, This is -4 to -2 is +2. This is -2 to -1 is +3. And 1 to 4 is +3. So -4 to -2. Let me plot that out. Actually, -4, -5. -2, -1. 1, 5. So it looks like it's going up 4. And then here it's going up 6. And then there it's going, well, I don't know. If it's going to the right 2 and up 4. And then it's going to the right 3 and up 6. So 2 to 4, 3 to 6. So if it's going up another 3, it should be going up another 6 if I have that right? So if I'm going to 4, 1, 2, 3, 4, then I should go to 11. So that's 5, 6, 7, 8, 9, 10, 11. So that seems about right. Oops, over here. So 5 plus 6 is 11. Now you could also find an equation. You could get the slope. So the slope is rise over run. So it's going up 4 as it goes over 2. So that slope is 4 divided by 2, which is 2. So your slope is 2. It doesn't give you a y-intercept, but that's okay because we can say y equals mx plus b. And if your slope is 2, and if we know that if we have a value of x we can plug in, for example, I could plug in 4. Y equals 2 times 4 plus b. And then, well, if my answer is going to be, well, that's a bad idea because I don't have b. So if I plug in 1, then my output should be 5, right? So 5 equals 2 times 1 plus b. So this is going to be 5 equals 2 plus b. 5 minus 2 equals b. 3 equals b. So it should cross at 3, which it looks like it does. So that's going to be your y-intercept. So if I plug in now, I know this is all complicated here, y equals 2x plus 3. If I plug in 4, that's going to be 8 plus 3, which is 11. So 11 should be your answer. All right, thanks for watching. Hope this was helpful. This is your last warm-up. Make it a good one.